Hi guys, it's time for another lesson. Today we're going to be talking about evaluating algebraic expressions. So yesterday we learned about all the different vocabulary words for this unit, and today we're going to talk about exactly when you will be replacing variables with numbers and then solving those algebraic expressions. And it's really important that we follow the correct order of operations while we do these expressions to find the correct answer.
Let's begin by reviewing our vocabulary words that we learned yesterday. So a variable is a quantity that can change, and we're going to use letters to represent variables. A constant is a quantity that does not change, and an expression is the mathematical phrase involving constants, variables, and operation symbols. In this problem, 6 plus 2x, 6 is the constant because it's not being multiplied by anything. X is the variable, and if you remember carefully, 2 is actually called the coefficient. That's the number that's being multiplied by a variable. So for evaluating expressions, we can evaluate expressions by plugging in a given value for a variable. So I want you to think about this as a machine. We're going to be inputting a value into an algebraic expression, and that will give us our answer, which would be known as the output. So in the practice problem 9x, solve if x equals 5, I want to put a 5 into my equation 9x. When I replace the x with a 5, it's going to say 9 times 5. When I replace that, 9 times 5 equals 45. So I'm going to put in the 5 and get out a 45. So let's try some practice problems. My new equation is 4x plus 8. If x equals 6, I'm going to put in a 6 where the x is, making my equation now say 4 times 6 plus 8. Based on order of operations, I know I need to start with multiplication. So 4 times 6 is 24. So now I have 24 plus 8. And 24 plus 8 equals 32. Now what if x equals 7? So my equation says 4 times 7 plus 8. Pause the video here to solve for the answer. If x equals 8, you should have found that the equation now equals 36. That's because we've added another 4. When we do 4 times 7, that's an extra 4 than 4 times 6. So the answer went up by 4. Our next equation is 12 divided by x plus 2x. Now, I really want us to remember, if we see a slash or a fraction, fractions represent division. So slashes and fractions represent division. So this says 12 divided by x plus 2x. Now, if x equals 2, what is the answer going to be? I'm going to have to do 12 divided by 2 plus 2 times 2. Now, multiplication and division are part of the same step, so we're going to do them in order from left to right. I have 12 divided by 2, which is 6, plus 2 times 2, which is 4. 6 plus 4 equals 10. So if x equals 2, then 12 divided by 2 plus 2 times 2 equals 10. Now what if x equals 4? My equation should now say 12 divided by 4 plus 2 times 4. I want you to think, do you think the answer is going to get bigger or smaller? And if so, by how much? Pause the video here to solve the problem. So if I do 12 divided by 4, I get 3, plus 2 times 4, I get 8. 3 plus 8 equals 11. So our answer got bigger. I want us to notice that in the division part, 12 divided by 2 equals 6, but 12 divided by 4 equals 3. So for the division part, our answer got smaller. But if we look at the multiplication part, 2 times 2 equals 4, and 2 times 4 equals 8, 8 is much bigger than 4. For our final practice equation, we're going to do x squared plus 1. And I want us to solve this if x equals 1, if x equals 2, and if x equals 3. Let's start by writing the equations. We should find that our equations now say 1 squared plus 1, 2 squared plus 1, and 3 squared plus 1. And I want us to think about what kind of answers we're going to be seeing. Starting with 1 squared plus 1, 1 squared, which is 1 times 1, equals 1, plus 1 equals 2. Hopefully everyone got 2. Now let's solve for 2 squared plus 1. 2 squared is the same as 2 times 2, which is 4, plus 1 equals 5. And our final equation, 3 squared plus 1. 3 squared is the same as 3 times 3, which is 9, plus 1 equals 10. So we call this pattern an exponential pattern, which means the answer gets bigger exponentially, meaning not equal increments, because the difference between 2 and 5 is smaller than the difference between 5 and 10. If this pattern continued and we did x equals 4, 4 times 4 would be 16 plus 1 is 17. So again, the difference between 10 and 17 is bigger than the difference between 5 and 10. So it's going up what we call exponential increments. All right, that's the end of our lesson for today. Hopefully you've taken some good notes and you've understand that this little machine, we're putting in numbers for our variables and getting out the answer.